In this video, I'm going to show you guys how to factor out the greatest common factor, namely the GCF. And before I do that, for the first example, I'm going to show you guys a connection between multiplying versus factoring, okay? So let's talk about this one first. We are going to multiply this with that, and you see we have 8 times x to the third power, y to the second power, right? This is technically just one term. So when we have to multiply, all we have to do is take this and distribute it to the parentheses, right? So let's see. We have to work out 8 times 5, and that's 40. The other coefficients, they are just the regular numbers. We just multiply them regularly. But then, when you have to multiply x to the third power times x to the first power, when we multiply the variables, when they have the same base, we are going to add the exponents. So x to the third power times x to the first, it will be x to the 3 plus 1, which is 4, like that. And here we have y squared. This has no y, so when you multiply, we just have y squared. And then we continue. 8 times negative 3, that's negative 24, and then x to the third power, here we don't have any x, so it will be just still x to the third power. And then y squared times y to the fourth power, it will be y to the 2 plus 4, which is 6. And now we're done. This is consider the answer if you need to multiply this and that, right? And now let's talk about factoring. I'm going to factor this out, and specifically, I want to factor out the greatest common factor. And by the way, I know what the answer is already, okay? But I'm going to show you guys all the detail because that's the most important part, especially the thought process, okay? So right here, this is the idea. We are going to factor out this expression, and let's take care of the number first. Here we have 40 and 24, right? The idea is that first, let's focus on the 40. We are going to think about it. What times what will give us 40? Well, we have a few choices. For example, 2 times 20 is 40. 4 times 10 is 40. 10 times 4, right? But the order doesn't really matter. How about 5 times 8, right? 1 times 40, things like that. And the numbers that I just mentioned, they are called the factors of 40. And now let's talk about the factors of 24. Well, we have a few choices as well. 1 times 24 is 24. 2 times 12, 3 times 8, 4 times 6, right? Those are also called the factors of 24. And now we are going to look for a common factor, namely a number that goes into 40, and the number should also go into 24. For example, we know 4 goes into 40, and 4 also goes into 24, right? So 4 will be considered a common factor. However, it's not the greatest one. We need to factor out the greatest common factor. And the answer to that is 8. Okay? Because for 40, we can look at 40 as 8 times 5. And then for 24, I can look at 24 as 8 times 3. And if you put this number down above it, it will help you. Okay? It's easier to see it. And you see that 8 is a common factor, and in fact, it's also the biggest one. And now, this is how we are going to do this right here. We should factor out the greatest common factor for the coefficients. Namely, we found it, which was 8. And then we have to take care of the variables. Let's look at the x first. And in fact, for the variables, it's actually easier. Because, for example, for the x, all we have to take out is x, and then look for the smaller exponent, which is 3, right? So we are going to factor out x to the third power. And we'll do the same for the y. So I'll put on y. This is y squared. This is y to the 6. Of course, we choose y to the second, like that. And this right here is the greatest common factor of these two terms. And now, we are going to open a parentheses for the leftover. Originally, let's look at the first term. It was a 40 here, but then we factor on 8. You can think about this as division. 40 divided by 8 is 5, right? So you have 5 left right here. Another way to do it is that you see 40 is the same as 8 times 5, but then you took out this 8 right here already. So of course, you have this 5 right here. And now let's look at originally here, we have x to the fourth power but then we took out 3 of them, right? 4, you take away 3, you have 1 left. So that means we have x to the first power. And then earlier we had y squared, but then we took them out already. No more y for the first term. And now we move on to the second term. This is minus, so let's bring it down because we factor out a positive 8, right? So this stays the same sign. Originally, this is 24, but then we factor out the 8, so we have the 3 left. 24 divided by 8 is 3. That's another way to think about it, right? Here, it has x to the third power, but then we factored it out already, so no more x. This is y to the 6th power, and then we took out 2 of them. We can just subtract. 6 minus 2 will give us y to the 4th power. And we are done. This right here will be considered the answer if the question is asking us to factor this expression out. As you can see, they are pretty much just the opposite of each other, right? Because, for example, when you want to multiply this out, you get this for the answer. But if you want to factor this out, you get back that for the answer. And this is the idea between factoring and multiplying. They are just pretty much the opposite of each other. And then the next example, we'll just be focusing on how to factor out the greatest common factor. Let's see how to factor out the GCF of this expression. And as we can see, we have 1, 2, 3. 3 terms, right? So be sure the GCF has to work for all 3 terms. And let's work on the number first. So what's the GCF for 36, 48, and 12? The answer to that is 12, because you can look at 36 as 12 times 3, right? And after you break down 36, put the result right here, right above it. It's easier to keep track. And we'll do the same for 48. 48 is the same as 12 times 4, right? And at the end, for 12, I can put this down as 12 times 1, isn't it? So as you can see, 12 is a common factor of these numbers, and in fact, it's also the greatest one. Therefore, 12 is the greatest common factor, the GCF. And now, we can put this down. Put down 12 in front. And in fact, in my opinion, the numbers right here is the ones that's harder to do. For the variables, it's easier because all we have to do is to pick up the smallest exponent. So for example, x squared, x to the third power, x squared. Of course, we picked up x squared, right? So that's it, the smallest exponent. And how about for y? This is 7, this is 8, this is 5. So of course, we picked up the smallest one, 5. We are going to factor out y to the 5th power. And this right here, it's the GCF of all 3 terms, okay? And let me indicate this right here once again. And now I'm going to open a parentheses and put down whatever that's left in all 3 terms. For the first term, originally we had 36, but then we factored it out 12, so we have a 3 left. And you can see that's a 3 right there. So I'm going to put down the 3 right here. Or you can just think about this as 36 divided by 12 give us 3, another way, okay? And originally, we had x squared, but then we took it out already, so no more x. This was y to the 7th power, but then we took out 5 of them. So we have 2 left, right? 7 minus 5, we get 2, so y to the 2nd power. This is it for the first term. And now for the second term, bring down the minus. Originally, we have 48, but then we factored out the 12. So we have this 4 left, or 48 divided by 12 is 4. This right here is x to the 3rd power, but then after you took out 2 of them, you have x to the 1 power left, right? So x to the 1st, just like that. You don't have to put on the 1. This is okay. And then for the y, this was y to the 8th power, but we took out 5 of them, so we have y to the 3rd power. Y to the 3rd power. And then for the last term, put down the plus first. And let's take a close look, okay? This right here is 12, but then we took it already. So technically, we have a 1 left. And that's the x squared. It's also been out already. the y to the 5th power is also being out already, right? So at the end right here, it is just a 1. That's it. This is the GCF, and this right here, it's the remaining part. And if you take this and distribute into the parentheses, you end up with the original expression. And this is the idea of factoring out the GCF.